Alright, what's going down? We're going to talk today about area of, let's start these with squares and rectangles. Okay? So let's first start with a square. And so a square, if you recall, is both a rectangle and a rhombus, which basically means we have four congruent sides and four 90-degree angles. Right? So equilateral, equiangular, regular, quadrilateral. So there's a little square. And most of you probably know the area of a square is the side squared. Right? Hence the clever name square. Area is the side squared. So we can look at an example, and let's suppose that we have a square with diagonal 10 inches. And so what's the area? Remember, the area is a two-dimensional space that something takes up. And in order to get the area, I'll show you a little shortcut for this later, but for now, we need to know the side. And so, remember, with a square, the diagonal creates a 45, 45, 90, really two of them. And so if 10 is my x root 2 side, then that means x is my 10 over root 2, which when rationalized, you multiply by root 2 over root 2. X really is 10 root 2 over, and then root 2 times root 2 is 2. And now 10 over 2, of course, is 5. And root 2 comes along for the ride. So what I just found was that that side's 5 root 2. And the other side's 5 root 2 as well. I think all the sides are 5 root 2, but I don't really care because I got what I need. And now I can evaluate, therefore, the area is the side squared. And since the side is 5 root 2, I'm going to square the quantity 5 root 2. Remember, when we square something like that, we square the 5 to get 25 times, and we squared root 2. And root 2 squared is 2. So you end up with 50 square inches. Alright, square inches because we're talking about area, two-dimensional. Alright, so that's a little area of a square problem. How about a rectangle? Let's get crazy. So here's a rectangle here. And a rectangle is basically a parallelogram with right angles. So here's a rectangle. And remember, these guys are congruent, those guys are congruent. You get all 90s. Everything's right. And basically you have two dimensions for a rectangle. You got your base and your height. Of course, if base and height are the same, you got yourself a square. But most of you probably know the area of the rectangle is base times height, the product of the two dimensions of that rectangle. And we can do a little example here. Let's use red. Let's get a little crazy. And let's say here we got this square, and let's stick with the diagonal. I like the diagonal problem. And let's say that diagonal cuts of a rectangle two 30, 60, 90 triangles. And furthermore, let's say that diagonal is, I don't know, 18 centimeters. What's the area? Well, in order to find an area, I need the base and the height. I can get the base and the height because I got myself a little 30, 60, 90 going on here. And I have my 2x side. Right? Remember, 30, 60, 90. 18 is my 2x side. Side across from 90, which is my diagonal of this rectangle. Also recall the side across from 30 is x. The side across from 60 right here is your x root 3. So down here, if 18 is 2x, that makes x, yep, you guessed it, 9. And so that means that this guy right here, x is 9, so I'm just going to replace that with a 9. And my x root 3 side right here, is since x is 9, is 9 root 3. And now I'm ready to get my area, which is base times height, which is the base, 9, times the height, actually 9 root 3, base, and the height is 9. So it's 9 root 3 times 9, and these 9s multiply together, outside times outside, and the 80 root 3 comes along, and that's going to be in square centimeters. Okay? So area of a square, side squared. Area of a rectangle, base times height. And of course, we're still using some of the right triangle stuff we've been using for quite some time now. So here are two practice problems for you. My gift to you. Number one, what's the area of this square So that's a square. And let's say the diagonal is 12. Number 2, let's create something funky. Let's say we got this going on, and we got this going on. And let's say that this whole side is 10, and that whole side is 8. And this whole side up here is 3. And this whole side right here is, let's say, 4. All right, what's the area of that? And assume we have rectangles. Assume right angles. In other words, all these ought to be right, are right, including this guy right here. Okay. 2 problems for you to consider. We'll talk about the solutions tomorrow in class. See ya. Have a good one.